Avila Finance students, we're now in the time value money calculations in chapter 5 and 6. So I want to walk through some examples in the textbook to help you out. Again, when you're reading these chapters, you're going to have to read them slow, and they give examples from both a Excel perspective and a financial calculator perspective, but I'm going to walk through some of the examples in Excel. The first thing, just to let you know, up here in this little f of x right here, if you click on that, insert function, and make sure you choose the drop down of financial, it's going to bring up a lot of the finance functions that you need. So we're going to use these to walk through some examples here. So first one, just going off the example on page 162, a future value. I've already input the rate, number of periods, payment, and present value. One thing about Excel is it looks at it from your perspective. So if you're investing, it's a negative cash flow. In the future, you're going to receive a positive cash flow. But if you are, say, wanting to know how much money you have to come up with today to have a positive future value amount, that's going to display that as a negative present value. So it's going to say, I have to invest this month to have that much in the future. But first, just in this future value, I want to pull this up and just kind of show you what I did. If I hit the f of x, and notice it's already in the FV, so I didn't have to pull it up. But I'm just putting in like rate, like here, I'm just selecting that rate. And notice it has to be in as a decimal form, 0.2 for Excel. And number of periods and payment. Payment's going to be 0 in this example. And the present value is a negative 1,000 because I'm giving a cash flow out and I expect to have a positive future value amount. And if I hit OK, we see that positive future value amount. And I'll put this Excel file out here as an example too. Number of periods, same thing. It's got the rate, payment is 0. Present value is how much I invested, what do I have in the future. Again, if I go to f of x, and this one was the number of periods. Let's say I didn't have that in there. If I just kind of delete that out for a second, then I go to f of x and financial, and I'm going to look for number of periods in PER. Say OK there. Hit the rate as 10%. The payment was 0. You can leave it blank if you want on the payment. If we don't have one, present value was the amount you invested, and the future value is how much you would have in the future. If I hit OK, it says it would take me 8 years to get to that, assuming this is an annual compounded rate. Notice the same thing for finding the rate. We can do the same thing too. If I pull that up, I get the number of periods, the payment, the present value, future value, and it tells me if I hit OK here, that would give me a rate of 11%. One thing I want to point out too, though, if you look at this, you got to be a little bit careful because I'd say in finance, you want to increase the decimal out to at least 4 places because sometimes, Excel will round, because this could be like 11.53 and sometimes, and you don't see the 0.53. So just push it out at least, 4 places. Present value, this is saying if I need to have $500 in the future, how much do I need to invest today if I can earn a rate of 6%? So I'm going to again pull this up just to show you. I pulled up the present value function, put in the rate as the 0.06, the number of periods is 10. There was no payment, and the future value was the $500. And if I hit OK, I see we get the $279.20 I need to invest to get that positive $500 in the future. Okay. Future value annuity due and present value annuity due. I want to explain this because an annuity due says you make a payment at the beginning of the time period. Like rent is an example, you pay at the beginning of the month. A future value of an ordinary annuity or regular annuity, you make the payment at the end. A lot of times the assumption is at the end, but in the textbook example, they give the annuity due. So I'm going to pull this up. This is saying, if I made a regular payment of, let's say it's a future value annuity, I make a payment of $500 at the beginning of every year. And I should change this to the future value here, make this correct future value. How much would I have in the future? So I'm going to notice I have future value here, but I'm going to put f of x, and I'm going to say, all right, the rate was 0.06, the number of periods is 5, the payment I was going to make a $500 payment at the beginning of each year. And this is very important. Notice the type is 1, and that makes it an annuity due when you do this for a future value annuity or present value annuity. If you hit OK, that's where they come up with that number in the textbook. Same thing with present value annuity due. It's saying that how much, if I were to receive a payment at the beginning of every year for 5 years, how much would I have come up with today in order to get that dollar amount to get $500 at the beginning of each year? So I look at that again, present value, have the rate in there 0.06, the number of periods is for 5 years. I'm going to receive $500 at the beginning of the year. And the future value is going to be 0. But notice the type is here, so you have to kind of like scroll down and find that type. If I take the type out, I'm just going to show you what happens. Well, let's just notice this 2232. But if I take that out, notice it goes to 2106, so it's a smaller amount. So because it gets that whole year to earn a return on it, but let's put that one back in, and we kind of get that number back in the textbook. Last one, just a payment. We'll explain this. They talked about on page 181. I'll get there with you guys. Yeah, they said, okay, you take out a loan for 30 years, or this one was actually for 300 payments, so it's less than 30 years. There was a 25-year mortgage. That's where they took, think about that. They said equals 25 times 12, and that's how they came up with 300 monthly payments. The rate, notice here we don't get charged 8% every month. We get charged 8% annually. We have to divide that by 12, so that's where we get that 0.0067. And then finally, we had the amount we borrowed, $100,000. So if I pull up the payment function, I look here, PMT, I have the rate right there. Notice it's got to be a monthly rate, the number of periods, the number of months, the present value, how much we borrowed, and then finally the future value just be 0, and that would tell me the payment of $771.81 or 82. Last thing I want to show you is if we go down here to the other sheet, if I can get to it here, is with beta. I did an example with beta too. This is in your next chapter. What I did here is I first just highlight. Important thing is the S&P 500 is the independent variable that changes. We want to know what the result is to Pepsi. That is, the stock market changes. How much did Pepsi's returns fluctuate? So if you have a beta equal to 1, it says that your stock pretty much follows the market. If you have a beta greater than 1, it's more volatile than the market. Less than 1, less volatile than the market. So all I did is I just kind of chose all these values. I did, can't quite see it here, but I have to do the insert function. And I believe I just did like a scatter plot. Let me kind of make sure of that. So I did a scatter. There's another one. And then I looked at one of these right blue lines and I right clicked and I just said add trend line. And over here you can't quite see it, but it pops up to the right. If I get it over here, I'm going to put an equation on chart. So there's that equation, and we see 1.04. So the beta for this stock is just a little bit more than the stock market, but not much. Okay, well those are some examples, so hopefully that helps you out with your calculations this week. And I'm going to put this file out here too to help you. So again, walk through the book slowly, make sure you can understand where they're coming up with the numbers.